out how to do it.
So, today as you look at our notes packet, if you looked through what we're going through for notes today, you'll probably notice that the only thing that's actually in our notes packet today is some additional proofs. The difference today is you're going to see some things popping up in these proofs, both today and Monday when we finish up notes for this chapter. You're going to notice some things that we haven't come across yet. So, we're actually going to start on our orange sheet. When it comes to our orange sheet, the front side, we filled in all the shortened versions, but the actual stuff in the boxes was already there. Remember, by the way, on the orange sheet, the only thing you should be writing on it is the things I write on it. But anyway, we already filled in the shortened versions on the front of it. On the back of it, we filled in the from diagram things. But the one thing we haven't come across in our proofs yet is situations where you're dealing with words. So, we need to talk about some of our words that are going to come up in our proofs today. And that's going to be today, and that's going to be Monday. Today, you're going to see things like supplementary. If you see the word supplementary in a proof, you're going to use the definition of supplementary, which we'll shorten down to def of sup. Note, I put two P's on there because it's not like S-U-P sup, like what's up. No, we're not doing that. That doesn't show up in the proof. I'm sorry. Okay. Now, when you come across something that says supplementary, it will say something along the lines of angle A and angle XYZ are supplementary. And if you see that, supplementary means two angles add up to 180. So within a proof, we can say the measure of angle ABC plus the measure of that angle XYZ is equal to 180. That's what definition of supplementary gives me. That's what the word supplementary gives me. Now, before I fill in any of the others that we're going to add to our repertoire today, I'm going to just make a quick note of something. Do you notice that in the middle of every single one of these definitions, there are the words if and only if?
What is equals to what? 180?
180. Do you notice those words if and only if on there? Every single one of the definitions has if and only if. If and only if is a biconditional statement. All definitions are biconditional. In other words, I can read them both directions. How that works in a proof? If I use my supplementary for an example, most commonly in your given, you'll see something along the lines of what's written first in that definition of supplementary. Angle A and angle XYZ are supplementary. And when you see that, you move to the part that comes after. But definitions can actually read both directions. So if I'm ever given a proof where I'm asked to prove something is supplementary, first, I get this, and if I get this, I can say they are supplementary by definition of supplementary. I can be given this and get this. I can be given this and get this. That's what the biconditional means, is I can go both directions with them, unlike other things. For example, segment addition postulate. If I see some segments add up to make another one, that doesn't necessarily mean they have a picture that looks like this. If and only if, those two things go both ways. Okay, another one we are going to see today is the word complementary. Definition of complementary is very similar to definition of supplementary. Def of comp. And complementary means two angles that add up to 90 degrees. So measure angle ABC plus measure of angle XYZ is equal to 90 when you see that they are complementary. Now the bisectors and the midpoints, those are going to come up on Monday, so we're going to skip over those. We're going to skip down to definition of right angle, which in theory you should already know what the definition of a right angle is. It's a 90-degree angle. So if you see angle ABC is a right angle, then in your proof you can write the measure of angle ABC is equal to 90. Yes, technically degrees. Def of and right angle, I do RT for right, and then I do the angle symbol. Definition of a straight angle is another one you should technically know already. A straight angle is an angle that measures what? Yes. So if you see an angle is a straight angle, you can say that the measure of that angle is equal to 180. Yes, degrees. No, I don't tend to write the degree symbol on this because I don't tend to write the degree symbol in the middle of the proof. Definition of congruent is something that will pop up more tomorrow. Definition of perpendicular. Actually, there's a perpendicular symbol. Upside down capital T is a perpendicular symbol. If you see that it talks about two things being perpendicular, you see that symbol, then essentially what you end up with is you end up with a right angle. That's what the definition is. So in this case, it would be angle AEC is a right angle. Okay, so those are the additional things that are going to start popping up in our proofs. We'll fill in the rest of our orange sheet tomorrow. Monday. Fill in the rest of it on Monday. Wait. You weren't planning on coming to school on Saturday to learn geometry?
No. Nope.
Neither was I.
I'm not going.
I can't blame you. I'm not actually expecting that you would. Okay, so we're going to shift over to our notes packet and we're going to start doing our proofs. I got 2 columns. Their titles. SR, statements, reasons. S goes first, R goes second, just like Sauk Rapids. Every single proof, regardless of the proof, starts with the given. Okay, my reasons given. My given information is measure angle ABD equals 27. Measure angle CBD equals 4x plus 3. Angle ABC is a right angle. And yes, even when I'm writing out the words, if I have a shortened version of it, I get lazy and write the shortened version of it in the proof. You are welcome to as well.
Did you also just say that it equals 90 degrees?
I'm about to get there. No.
Why?
In a proof, you have to write down exactly the information you have and exactly the information that our postulates and our theorems and our definitions give us. So I cannot skip to angle ABC being 90 degrees, even though I know that it's 90 degrees because I know it's a right angle. But here's the thing. When it's something that you know, Like, you know angle ABC is a right angle. You know that because it's its definition. That is actually going to tell you that that's going to be probably the next thing you do in your proof. If you didn't think of that right off, remember, go back to your 5 things. The first thing we look for is words. Do I have a word in my proof right now? Yeah, I've got right angle in my proof. And so I go to my orange sheet and I find where it says right angle, and the definition of right angle says I can change it to 90 degrees. Now, you probably didn't need to look at your orange sheet to know that, but that's the process you go through. So I can say measure of angle ABC is equal to 90, but it has to be its own step. Reason we knew that? It was the definition of being a right angle. Okay, now what? I go through my proof. I look for 5 things. I look for words. We had words, but we took care of the words. There's no additional words. Are there symbols? No. Symbols I'm looking for are congruent, perpendicular, and parallel. None of them are in there. Is there a situation where I could do substitution or transitive property? I would require the same thing showing up in the proof twice. I don't have that. Now, some people like to point out this. I see angle ABC showing up twice, but there's some key things to focus in on that and as to why that can't be substitution. One, the reason I have this is because of that. That's a problem. But even if I didn't have that, when I'm looking for 2 things or something showing up in 2 places, it needs to be the exact same. In other words, the fact that this has a measure and that one doesn't, not the exact same. And it has to show up with things like equal signs. Words is not helpful to me in it showing up in. Anyway, I go on. Is there algebra I can do right now? No, I can't solve any of these equations. 5th thing I look at is the picture. I look at that picture. There's only 2 things I get from pictures, is these 2 things. Does that picture look at like it could fit with either of these? Yeah, I've got adjacent angles in it. So, I could say measure of angle. This little one is ABD. Plus measure of angle. This little one is CBD. The big one, CBA, or I notice early in my proof I have ABC, so I'm going to do ABC. That was angle addition postulate. Did I have to write the lettery version? Yes. You have to write the lettery version. That's what the postulate says you can do. Do I have to keep the lettery version? No, we're going to substitute. ABD gets replaced with 27. CBD gets replaced with 4x plus 3. ABC gets replaced with 90. That is substitution because I'm replacing something with what it's equal to. And now it's just algebra. What would you tell me to do first? I would combine like terms. 27 plus 3 is 30. 4x plus 30 equals 90. Combine like terms is the reason? That's a simplify. When in doubt, it's on your own sheet. Then what would you tell me to do? Subtract the 30. 4x, 90 minus 30 is 60. I did subtraction. SUB? that far enough?
No,
TR. All the way to the R for subtraction. Next thing you tell me to do? Divide by 4 and we get 15. X equals 15. That was dividing. Am I done?
Yep.
How do I know it?
Because the proof says that.
Because it's what I'm trying to prove. It matches the proof perfectly. I'm getting lazy in writing the statements and reasons, so I'm going to do the SR. Jasmine, how do I start? Yep. I put given in as the reason, and I put the measures that I know. Why don't I put the parentheses? They're just a placeholder holding on to the degree. If they were there for anything other than a degree symbol, would I need them? Yes. Okay. What do you notice? Words! I get the word straight angle. If an angle's a straight angle, what do you know about it? It's 180 degrees. Angle WXZ equals 180. Is that correct? Measure of angle. Calling angle XYZ without the little m symbol is like saying angle XY, or sorry, not XYZ, WXZ, is like saying its name is that number. It's like calling you by your age and expecting you to answer. It's like me saying 15 here. Thanks, Jackson. But generally speaking, you're not going to answer. Okay. Cam, why did we know that? How did we know WXZ was 180?
Me?
Yeah, you're Cam. I saw straight angle. What on here has straight angle?
180.
True. What's its name? Look in the bolded stuff. Find straight angle.
What about it?
What's it called?
Definition of straight angle.
Yeah, it's the definition of the straight angle. Ava, what would you like me to do next? Angle addition postulate, because we don't have words, we don't have symbols, we cannot substitute or do transitive property, nor can we do algebra. So we looked at the picture, and I see two angles right next to one another. Angle, add, post. Jackson, what would angle addition postulate look like for this picture? Just like that?
Don't you need the measure?
Oh, measure.
Don't I need the measure and the angle symbol? Yes.
My brain's not functioning yet.
Hmm?
My brain's not functioning yet.
Here's the thing. You told me the right things, and I have zero doubt that on your paper you probably put them. You just didn't say them aloud, so I was going to write down exactly what you said. Okay. Kylie, what would you tell me to do next? Substitution. You got it. S-U-B-S. Aiden, what would that substitution look like? Beautiful. No, I'm kind of writing a little bit smaller than normal. Olivia, what would you tell me to do next? Oh, we get the wrong word. It's okay. Tell me what to write mathematically. How about that? Are you talking about these things?
Yeah.
And that's where your brain came up with distribute. It's the wrong word, but you knew what you were doing. 3x plus x is 4x. 1 plus 31 is 32. I knew you knew it. We just forgot the word, and that's okay. Technically, it's combined like terms, or actually more technically, what do we put in the proof? Simplify. Y'all know the next step. Subtraction. The key thing people forget is to go all the way to the R. Subtracting 32 from both sides, I get 148. And then we divide. $37?
Yeah.
Sweet. Am I done?
No.
What have I not done? Haven't matched the proof, so I need to plug back in. I'm looking for the measure of yxz, so measure angle yxz equals, well, yxz is this x plus 31, so it's 37 plus 31. Add those together, and I get 68, which is what we're trying to solve for. What is plugging it back in called? Yeah, I'm hearing the whispers. Substitution. And what is actually doing the adding of them together? It's not adding. Simplifying. Adding moves something from one side of the equal sign to the other. If they're on the same side and you're putting them together, it's simplify.
Will substitution always be followed by simplify?
Technically, no. Will it commonly be followed by it? Yes. It's rare that you plug something in and you don't need to simplify. But it can happen. Okay. Our last two examples today, you'll notice come without a picture. You don't need a picture for a proof. unless it's the type of proof that uses one of those two diagrams. And then you need a picture. Oftentimes you'll have proofs that don't need that because they have enough information already. And this isn't the first proof that we've had that doesn't have that. But it's been a bit. %99 of the time, if you're going to have a proof that does not have a picture to it, it's one of two things. Either it's already set up as algebra and you're just straight up solving. Or option two, it's going to have words that tell you what to do with it. I see the word complementary. Complementary means two angles that do what? That's congruent. They are often different. You get an orange sheet. Complementary should be on it. Complementary means they add up to 90. If DOG and RAT are complementary, that means the measure of angle DOG plus the measure of angle RAT is equal to 90. That's what that word means. And if it's what something means, it's its definition. Now, oftentimes when you're dealing with complementary and when you're dealing with supplementary, you're going to see proofs that actually look fairly similar to the ones we've already been doing. Because typically once we see an equation like this, I start to notice that I've got measure of angle DOG and measure of angle RAT popping up in two different equations. One of which is equal to things, which means I can follow it up with what? Shows up in two places. Starts with an S. I can substitute. I can plug things in. 3x plus 9 plus 5x plus 1 equal to 90. I won't have to plug something into that last one because I already know it's 90. It is possible to do substitution where you only replace some of the things. You don't always have to replace all of it. Jackson, is this one going to follow up with simplify? Yeah. Substitution will often follow or be followed by simplify. And it will often be followed then by doing some algebra. I'm going to do the algebra here fairly quickly because you all know the algebra. After we finish the algebra, what do we have to do? Is that what I was trying to solve for? Is that what I was trying to prove? No. So I plug it back in. Do you notice that this problem is not that much different than the ones on the previous page? I plug back in, which is substitution. I do the math to get there. 3 times 10 is 30 plus 9 is 39. very much the same as what we were doing. We've just added some things to our proof in the form of words. Today you're going to have a worksheet. Try out the last problem on your own, and I'll be coming around much like yesterday. Much like yesterday again, I also am going to make sure that I get in the video of me going through it, so I'll start walking around here in a minute.